Cool. So what we got from Han there was sort of the sense that of the shape of the problem and what we need to be aiming for, which is this broad ability to verify retrievability. I think in general, as we think about this retrieval incentive problem, there's a few things that we can then align on that's worth sort of that next level of getting into. There is a top level choice that I think there is still some debate on. There's the path that Juan laid out of having this network of verifiers, and that's got one set of trade-offs, but is probably the more practical thing that we have gotten started on building and that we can be building. There's another set that we've prototyped through retrieve.org that's a slightly more cryptographic based structure, where instead of having external measurement of a checker network that's attempting to retrieve things, you instead first negotiate some sort of like passes that are like download passes or some sort of token that is redeemable for a download. And then you have a subsequent phase where people can redeem these tokens that they've bought from a provider in exchange for getting data. So there's sort of two paths there. There's one path, which is if you have things either open or you expect general public availability of data for clients, then on top of that, you can add a measurement layer that makes sure that you're getting what you think you should be getting, which is not using that sort of cryptographic thing. And then the second one has much more of an economic tie-in, which is we're going to say that retrievals cost something, and then can I have that economic of some sort of token that I redeem? And at the point that you've got a token that you redeem, you've got some token type flows. So you could have this signature is something that the SP is collecting, and then it can redeem those to get the money back for the cost of those retrievals. So there's a set of protocol-based things that can happen in that framing that the retrieve protocol sort of provided a template for. I think what we're finding is that is still relatively high overhead in some sense in practice, where for small downloads, so think something that would be like online HTTP, it ends up being a lot of overhead, especially if you're trying to do an on-chain redemption of these, such that in either case, we're going to need things like these IPC-like things to get the cost and efficiencies of those protocols low enough for that to be practical. So I'm going to talk a little bit more about retrieval expectations and sort of what we're actually meaning when we talk about this retrievability, and how we can get more concrete tiers here besides just saying this should be retrievable. Like what do we actually mean here? Because we've now said that for a while, like Fil+ should make data retrievable. And if we just leave it at that level, and I've seen a range of definitions from things like it should be retrievable 95% of the time. It's like, if we don't actually precisely define what that means down to a level that includes things like with what bandwidth, with what latency, how many times, we have created an unbounded cost for a provider that makes them very wary to actually live up to that. Because if they have to provide 95% of the retrievals, that is an infinite network cost that they have signed up for, which is not the reality. And so we need to get these to align back to reality and converge. So we already got sort of that view of the different timings from Juan in the previous talk, but we see throughout most of the storage and retrieval industry that there is a tiering here from multiple layers of Glacier and archival, multiple layers of something that's online or S3-like, and then CDN-ish, right? Like there are these different buckets of service where you'll either prepay or pre-negotiate for some SLA, some class of service, based on an expectation of what your usage is going to be. And so you've agreed, here's my expectation, more or less, of what my usage is going to be. If I don't know, I may have to pay for a class higher, but I'm making sure by setting it there that it's something that the counterparty can agree to. And so the interesting thing here is as you look at these like deep storage things, we're talking about data that's, the disaster recovery where I'm hoping I never need it, or I might need it once a year or something like that. And that moves up to, okay, maybe I need this once a month or something like that. And by the time you're trying to get it more frequently than once a month, you're up to sort of these S3-ish levels rather than the Glacier and archival. So how do we then translate that into what we actually need from retrievability? I think the other like useful thing that let's keep in mind is where our SPs are and where the SPs around Filecoin are. This is from the beginning of this year, I think, or from last year, from 2022. And we were seeing large entities that have order of 100 petabytes in one place. Most of them are, under 10-ish. There is a set of reasons why an entity will splinter into multiple that are all appear as small, rather than sort of necessarily having one provider that has that really large thing. But if we're solving for retrievability by thinking about what's practical and what we would expect from a provider that's, say, 5 to 10 petabytes of storage, that thing is something that probably we can imagine thinking about, okay, how do we handle how would someone who's 2 orders of magnitude bigger than that, or 1 order of magnitude at least, be able to cope with this? How would people who are smaller than this be able to cope with it? So this is the rough amount of data that if we can solve it here and think about what this actually means in terms of cost, we've got a handle on some things. So we've got sort of these classes. As you get down to the bottom, disaster recovery, cold storage, you start to get to large amount of data where the actual retrievability plan is you want to like ship hard drives, right? It's not necessarily worthwhile that you would expect that to be an online data transfer. That'll start to get pretty slow. And if I've got my 100 petabytes of data and my main data center like falls over, what I actually want is to figure out how to, within a day or two, like get the container truck overnighted by air to get those disks back so that I can keep doing them. So at that cold storage tier, if that like gets solved a little bit later, that's probably not the end of the world, is probably one way to think about that. That it's this archival where you're at around once a month up through public. That's probably the 80% of what we need to think about at Filecoin, and that we'll have other things handling CDN at one end and physical things handling the really like large but infrequent case at the other end. So let's walk through now an example, because I think this is an interesting just set of numbers to think about. If you've got a provider that has 4 petabytes of storage, this is like around that P50 of what a provider might have. So this is like the average provider. And we say, let's claim all of the data that we've got now is archival data. And let's see what we mean by that is over a 6-month lifetime, we're trying to get it back 4 times. Maybe that's a little too much, but it's not that much too much, right? That's under once a month. That's like, if I want to replicate this 3 more times, I'm going to need to do 3 retrievals. So like in this range, and then like one person like checks it for a retrieval bot. So like that it has been retrieved 4 times over its lifetime, we're not too out of whack here. For that to happen, we are using 7 gigabits continuously for the entire 6-month period of this data. So anything less than a 10 gig connection, and we just can't get that data off over its 6-month lifetime. So we can try relaxing some of these, right? Like, let's say we're going for 18-month duration of our deal, and let's say we're only getting it back once exactly, and that gets us down to something like 600 megabit connection. So if you've got a provider who's like our average provider and they've got a 1 gigabit connection, that sort of barely lets us get that data off once in the longest sector that we can have right now. So this is roughly the largest provider that could survive at a baseline of a single retrieval of that data. Like, is it responsible to store any more data on this provider? Like at some point this falls back to a storage problem where we're like pretty close to that, which is if you're at a gigabit at some point we need to say, actually, we can't store more because we can't get it back off, like even once, because the amount of like bandwidth that you have is insufficient for us to at the expiry of that data, pull it off. And we have a non-negligible number of providers where we just like, we can't get the data off before it expires. And so we have to either extend the deal and let them make the deal again, or that data is just, there's not time to get it off before it expires. So we've got one framing here that I think is a useful baseline, which is what is that expectation for how many times that data needs to come off? And I think in general, it's probably going to be at least 2. Like that, but we're still at this very bare sustainability question here. We haven't gotten to the, how do I actually get to retrievability?
It might have to do with the distribution of retrievals. Like for example, if that is very long-term archival backup data that is not meant to be, where like the expected retrieval time from a client is like 0.2 or something, or 0.1.
Yep.
It might be more okay, but I think it's a great point here around really checking the actual link capacity and relating that to the total storage that could be available on a particular site.
I think this is also splitting what does Filecoin need for replication and sustainability of data from retrieval. Like we haven't gotten to the retrieval of like, I want my data for this use case or for my application. This is purely, if I'm going to have another version of this data in a year and a half with different providers, what do I need to be able to have that flexibility? So we can now start to look at what happens when the client actually wants their data. So let's say you go from your 100% archival and say, let's say 25% or some fraction of this data, we move up and we say, instead of doing it like once a month, we want once a week. We actually have some use of it. And you see that your bandwidth here is roughly doubling on that. And so the interesting thing is that's not actually that scary to go from archival level to these online levels. That the cost there of some fraction of your data becoming hotter is much less of a jump in some sense. Like this is doubling, but that's the fact that some of your data is getting used is not as scary as going from that 1 to 10 gig. Like to go from 10 gig to 20 gig is a doubling of your cost. To go from 1 gig to 10 gig is potentially more than that. And so there's a lot of stuff that we can do that's still fairly practical here. If we're trying to do CDNs, that changes a little bit. So here's like, we're going all the way up to saying this data is happening once a day, and now you need a 100 gig link, and that gets probably a little bit scary. So this is maybe starting to get worrying to people, is that hosting that class of data of I'm going to be getting every 32 gigs that I'm storing results in 32 gigs of retrieval bandwidth per day. That's pretty hot content. And so we're going to need to draw our line of where we say this isn't necessarily reasonable, and this needs to happen with CDNs and a layer above us, somewhere below this likely. And then do I have I don't know if I have a CDN one here. But I was trying to do like hourly and stuff, and like the other option that you've got is you can lower your size. So as you think about like what does a CDN node look like here, it probably doesn't have 4 petabytes. It probably has like at most 100 terabytes, and at that point you can be doing hourly retrievals of this data and still be on a pretty reasonable link. So you've got a couple options, but in thinking about what these storage nodes are, hopefully this set of numbers gives us some landscape of like what's realistic here, which is for online hot retrievals, we should be expecting 100 gigabit links. But if you're mostly archival or you've got someone above you, you can get availability with a 10 gig link pretty reasonably, but we're really going to need to struggle from that 1 gig-ish that a lot of storage providers have up to 10 gigs before we're going to get that delta cost of retrieval to stop worrying about.
It might be really cool to create a graph that has the size on one axis and the bandwidth on the vertical axis, and then a line per number of retrievals, like those that you chose, like once in a lifetime, once a month, once a day, and that'll then suggest specific like tiers of bandwidth and like regions where like an SB should be in like this region, but not this region or something like that.
Totally. Yeah, I think that's right. I think there's a couple other like complexities of network reality that we're staring at, which is any individual download is not getting this number, right? Like that you have a 10 gig link does not mean my download happens at 10 gigabit. Like my download is going to be probably at best tens to 100 megabit. And the way that you're saturating your link is through many simultaneous downloads. But that also means that it's very hard for a measurement system to say, yeah, great, there's enough bandwidth capacity for this provider. When they're one of many concurrent requests happening, they're getting one small slice of that bandwidth that's available. They're getting some throttling. And then in particular, the other like tough complexity here is a provider has a lot of data that has different expectations of retrievability. Some of it's archival, some of it has an explicit, I want this to be publicly available type things that maybe are agreed to externally. And so the place where a provider is going to potentially fall below that expectation of SLAs is not that they don't have enough bandwidth to serve your specific deal. It's that in aggregate over all of the deals they've got, they don't have enough, they've oversubscribed such that it's going to be an occasional failing across all of those deals. It's not necessarily that your deal will fall below 95%, or even if your deal does, or that conversely, that when your deal falls below 95%, that means that the provider overall has fallen below their SLA. And so being able to extrapolate and get that whole picture of the full set of deals and the full SLA performance of a provider takes a lot of data. So I think there's a couple things that I'm trying to push on. Is deal renewal important? What percentage of nodes have enough bandwidth for data to be retrieved once before expiry? And at what point is it irresponsible to store more? I think this is a framing that is probably the most actionable for us right now in going from the current world to one where people are properly permissioned or provisioned to have some retrievability. So to get that baseline hardware up to 10 gigabit, I think this is probably the framing that I'm starting to go with in advocating for that. And then I think the second discussion that we can have is where are these specific lines that we want to describe for, I want my data to be publicly available. What does that actually mean? Does that mean that I should be expecting and asking an SP that I want to be re-downloading this once per day, or that someone in aggregate, this 32 gigs should end up expecting 32 gigs of retrieval over that content per day? Versus per week versus per month, or are there other tiers that are probably more aligned to the reality? And we can look at existing cloud providers to see if there's other places here. But I think having a default set of these, then where we can say, okay, this is in public class versus this is in archival class, then it gives us a more concrete set of bullets of, is this being met? Which lets us simplify the problem a bunch. I think those are the 2 points that I wanted to make in what retrieval expectations actually are. Thank you.